Today let's talk about differences of squares. The basic formula for differences of squares, for factoring differences of squares anyways, is you have a squared minus b squared. You have to have a square in the beginning, a square in the end, and a minus sign in the middle. This can automatically be factored out to a plus b, so that's the square root of the first one and the square root of the second one, times a minus b. One's a positive, one's a negative. Let's use it. Here I have x squared minus 9. Now looking at it, for my first one, x squared, I have a square. My second number is 9. I have a square. And in the middle, I have a negative sign. So this we can use difference of squares. So to solve this question, I'm going to factor it out into two parts. I take the square root of my first term. Square root of x squared is just going to be x. X times x. And then take the square root of my second term, which is 9. Square root of 9 is 3 and 3. And then I make one a positive, one a negative. And that is my end answer. Let's do another example. I'm going to go a little more complicated. Oops. Delete that one. So, undo. Let's tuck this out of the way. So, new question. I'm going to go 9x squared minus 16y squared. Once again, checking. I have a perfect square there. 9 is a perfect square, and x is a perfect square. X squared, I mean. Same thing there. 16 is a perfect square. Y is a perfect square. And I have a negative sign in the middle. So I can solve this using the difference of squares. Draw out my brackets. Let's start solving. Starting with my first one, square root of 9x squared. Square root of 9 is going to be 3. Square root of x squared is just going to be x. So my first term is 3x. Now we switch over to my second term. Square root of 16 is 4. Square root of y squared is y. So my second term is 4y. The last one is very easy to read. And put a plus in between one set, minus in between the other, and I have my square root. And that, in a nutshell, is the basics of differences of squares, factoring differences of squares.